If that's a wireframe model in R2, could you guess the next thing we're going to do? Yeah, so we'll call this 3.1.4, almost like pi. And we'll call this a wireframe model in R3. What did a wireframe model in R2 require? What are the two different important features that we had? Vertex matrix and edge table. Edge table was connectivity. Vertex matrix was the corresponding pixels that I wanted to turn on and off, right? Let's create a pyramid in R3 using a vertex matrix. And in this case, could you guess the number of rows that it's going to have? 3. Why would it have to have 3 rows? Because 3 coordinates for every single vertex. Could you guess the number of columns? And in this case, I want you to visualize a pyramid. You should have 5 columns. So guess what you just did? You just constructed the dimensions of a matrix based on the geometry that you know from your lived experience, right? Welcome to math modeling. Could you guess the easiest place to start a pyramid? Yeah, I started at the bottom. Now I'm here, right? What's the easiest vertex that you could possibly choose? Yeah, that's the goal. If you had a choice, would you like to go negative or positive? Positive, and maybe you'd first want to go positive along the x-axis, and then just to be a little exotic, maybe instead of 1, we'd say 2. All right. If it's 0, 0, 0, 2, 0, 0, and the bottom of my vertex is a square, what would the next one likely have to be? Yeah, there we go. 2, 2, 0, right? Now, what did you say? 0. And now the question will be, well, what's my last vertex there? Or vertex? What's my last one?
1, 2.
Yeah, okay, so 1, 1, I guess I should look at the one. Yeah, okay, cool. Did you read the notes beforehand? Damn, dude, you intuited that. That's cool. That's exactly the one I chose. All right. Can I make a claim? That's pretty cool. Damn, Joe. Here's a question that I have for you. What is the most fundamental geometric object that's not a line? Triangle, right? In R3, would you agree that I can build almost any shape out of triangles? They're not, I mean, you could build my shape out of, I always thought about doing this with my sons, like model my son's face using triangles. And then I'm like, I'd like to sleep at night, so I don't do that, right? At some point later today, maybe Mike will talk about some of the stuff that Mike Sassman has told me about, where physicists actually have this, I forget what it's called. They have this box that shoots out lasers that like scans the room, and then will turn those lasers into coordinate systems that will have a 3D model of the room just from the scan. What's that called again? I forget what that's called right now. Michael's always trying to convince me of that. That's awesome. God, Mike, that's cool. All right, so we have a vertex table. Could you guess, or vertex matrix, could you guess what we need next? Edge table. How many edges would you need if you were to create an entire triangle, or excuse me, a pyramid from only triangles? Say it again? Yep, guess what you're doing right now? You're applied math modeling. You're using your brain to think about the stuff that you want to start with and the stuff that you want to end with. I lied, Henry. I take it back to the thief that was not. So here you would probably need what we call a start vertex, and then you would need what we call the. How many of you think that I should try to draw this by hand? All right, cool. I guess we should probably use the right hand rule, since Math 1C is indeed a prerequisite. The visual looks like this. We've got the x-axis coming right out from us here, and it's positive along this way. And then the y-axis is along the board. And then the z-axis is pointing upwards, so the axis looks like this. Where's the first vertex there? 0, 2, 0, 0. So I go 2 along x, 0 along y, 0 along z, and I call that v1. Where's the next vertex? Oh, sorry. Yeah, you're right. Okay, what's the second one? I'm sorry. Okay, and then what? Yeah, so now I've got v3, and then v4, and then I go 1, 1, 2, but I've kind of got to trace that thing a little bit, right? And then instead of trying to imagine this without drawing it, let's just make the connections that we would want. What connections would we make? We'd probably want to do the base first, right? So connect 1 and 2, 2 and 3, 3 and 4, 4 and 1. Do I need it to be directed if it's just going to be a regular pyramid? Yeah, so maybe I don't talk about directions, right? All right. Next ones? 1, 5. Yeah, so maybe I should call that V5. And then anybody have a rotten tomato you brought with you? Please throw it at me at this point because I'm just butchering this diagram, right? What am I missing? What's the one thing that I haven't done yet? The bottom is now constructed as a square, but the claim is that we're going to construct everything from a fundamental geometry, which is a triangle. So in this case, I have to make a choice. Which triangle am I going to make? Looks like I did V1 to V3. I'm sure there's a scientific reason why I would choose, maybe if you have a rule that you always use the smallest possible choice. Like if I did V2 to V3, V2 is bigger than V1, so that's not the smallest choice, right? Just to avoid ambiguity. Let's go ahead and list the edges. Edge 1, maybe we said connected vertex 1 and 2. What did edge 2 do? 2 and 3. What did edge 3 do? 3 and 4. What did edge 4 do? 4 and 1, or 1 and 4. If I'm not caring about order, it doesn't really matter. Edge 5, I mean, I guess it really depends on what we define to be edge 5, right? I think I actually did edge 5 to be, yeah, I think I did this in a different order. That's okay. So you said that this one maybe we'll keep in that plane. 1 to 3, edge 6, edge 7, edge 8, edge 9. All right. What is 6 in this case? 1 to 5. What's 7? 2 to 5, 8. 3 to 5, 9. 4 to 5. Could you imagine what we would do to do geometric transformations on this thing? If I actually wanted to make this thing move around in space, what would I do to it? Move the vertices. Would I have to change the edge table? No. The edge table is a deformation of the actual shape. Changing the vertice allows me to turn this thing around. What if I wanted to make it bigger? What would I do? Scalar multiplication. That would just go. What if I wanted to shift it? Vector, or yeah, in this case, matrix addition, right? I could shift all of them by just adding a particular matrix, right? Or I could just shift some of them. What if I wanted to cut it up? What would I have to do? Manipulate the edge table, right? And maybe create a bunch of different polygons. Like if I wanted to, like, intersect it with a plane at z equals 1 and then create the top piece and the bottom piece, all of a sudden I'm creating new edges between vertices. I'm creating new vertices and I'm creating new edges between vertices that didn't exist beforehand.